Welcome back to Think Cosmos, where we ponder the universe's deepest secrets and wonders. Imagine trying to snap a photo of a spaceship streaking past at nearly the speed of light. To your eyes, something mind-bending would happen. The ship would look strangely distorted, even appearing rotated from its actual orientation. This isn't science fiction or a trick of the camera, but a real consequence of Einstein's theory of special relativity. Scientists have long known that objects moving close to light speed experience weird effects like time slowing down and lengths contracting. But back in 1959, two physicists also predicted another odd visual effect. A fast-moving object should look as if it's been flipped or turned. For decades, this idea, called the Terrell-Penrose effect, remained unproven because we couldn't actually see it happen. After all, we don't have spacecraft going 90% of light speed to photograph. Now, a team of researchers in Austria has found a clever way to demonstrate this trippy effect here on Earth. They essentially created a miniature light speed scenario in their lab by using high-speed cameras and carefully timed laser flashes. In their experiment, they moved a cube and a sphere in front of a camera while flashing lasers at incredibly short intervals. They even distorted the shapes, squashing the cube into a flatter cuboid and the sphere into a discus to mimic how objects contract when nearing light speed. Then they simulated a world where light travels much slower than it actually does, only a couple of meters per second. That slow light setup let them capture how light from different parts of the moving objects arrived at the camera at different times. And sure enough, when they pieced the images together, the fast-moving objects looked bizarrely transformed. As one scientist described, a cube appears twisted, a sphere remains a sphere, but the North Pole is in a different place. In other words, the cube looked kind of skewed and the sphere's features seemed shifted, just as the relativity theory predicted. What's really happening is an optical illusion caused by the finite speed of light and the motion of the object. Light from the far side of a speeding ship takes just a tad longer to reach your eyes than light from the near side. Your brain or camera sees all that light at once in a single frame. So you end up perceiving the far side of the ship as it was a moment earlier in time, from a slightly different position. That makes the ship look distorted or rotated when it's really not. The astronauts on board wouldn't notice anything strange with their ship. It's an effect only an outside observer sees. It took an ingenious bit of lab work to finally show this effect in action, because we can't accelerate a real spaceship to relativistic speeds yet. By slowing down the speed of light in the experiment, in a manner of speaking, and adjusting the objects, the researchers basically slowed the scenario enough to capture it on camera. It's a striking confirmation of special relativity's predictions, one that's both technically impressive and kind of mind-boggling to witness. This experiment reminds us that the universe plays by very different rules when you're moving near light speed. If someday humans build ships that can approach such velocities, we might have to get used to some truly strange views out the window. Imagine watching another spacecraft zip by and seeing it appear warped and twisted. It would be like a funhouse mirror in space, caused by physics. For now, we can only recreate these scenarios in labs and computer models. But proving that this wild visual distortion really occurs brings us one step closer to understanding the extreme limits we may encounter in future space travel. Einstein's theories continue to hold up, even in the most extreme and imaginative situations we can devise. The Austrian setup also hints at practical spin-offs. Ultra-fast imaging techniques born from this research could aid next-gen telescopes. Those telescopes might one day catch natural cosmic objects, like pulsar debris, zipping by and showing real-life relativistic distortions. Engineers are already considering how relativistic optics might affect autonomous navigation for probes propelled by powerful lasers. If a light sailcraft races ahead at 20% of C, its cameras will face the same skewed view Understanding that view is crucial for steering. The experiments? Slow light trick uses metamaterials that force photons to crawl, a technology now being studied for advanced optical computers. Such photonic processes could simulate relativistic scenes in real time, letting mission planners rehearse high-speed flybys before launch. There's even a medical angle. Researchers think similar timing offset methods could sharpen high-speed CT scans, catching rapid changes in living tissue. So a relativity test born in a physics lab might end up improving both space probes and hospital imaging. Looking further ahead, imagine tourist rides on subrelativistic starliners, where window displays correct for optical distortion, offering a true vista of space. Conversely, thrill seekers might ask to see the raw feed, enjoying the psychedelic twist of planets and moons warped by velocity. Artists could exploit the effect for immersive relativity galleries, projecting live distorted views from orbiting cameras onto giant screens. All the while, the core lesson stands. Nature's speed limit isn't just about how fast you get somewhere. It also scrambles perception itself. Every photon has a story to tell about where and when it left, and at high speed those stories arrive out of order like shuffled postcards. Put them together, and reality bends into shapes our everyday intuition never prepared us for. Back in 1905, Einstein warned that our common sense notions of space and time would fail at extreme velocities. The Terrell-Penrose effect is one of the most vivid illustrations of that warning, a reminder that motion, distance, and simultaneity are relative. Proving the effect after 60+ years closes a chapter in theoretical physics and opens a fresh playbook for experimental imagination. Next, researchers want to photograph more complex objects, maybe even a detailed 3D face model, whipping across their camera's field. They're also exploring polarized laser pulses to see how different wavelengths reveal separate layers of distortion. Meanwhile, computer graphics teams are updating rendering engines for movies and video games to depict light-speed chases with newfound realism. Future sci films might finally ditch this stretched starfield cliché and show ships twisting subtly as they roar past the camera. Educators are excited too. Portable kits based on the Austrian design could travel to classrooms, letting students see relativity with their own eyes. Such demonstrations make abstract equations tangible, sparking that moment when physics clicks. On the theoretical side, some researchers wonder if similar optical timing effects occur near black holes where gravity warps space-time. Observations from the Event Horizon Telescope might reveal comparable distortions in the glowing plasma swirling around a black hole's edge. In that sense, studying a tabletop cube helps decode the visual chaos of the most extreme objects in the universe. The quest doesn't end here. Every new measurement refines our models and challenges us to seek deeper truths about motion and light. Eventually, we'll need this knowledge for real spacecraft traveling to Proxima Centauri or beyond. When that day comes, pilots will rely on algorithms that factor in Terrell-Penrose distortions to interpret sensor data correctly. Otherwise, a warped asteroid could look farther away or oddly oriented, leading to navigation errors. Thus, today's curiosity-driven lab work has tomorrow's safety implications for interstellar voyagers. Einstein gave us the rulebook. Modern scientists are running drills to be sure we can play by those rules when we finally step onto the relativistic field. So the next time you watch a sci-fi chase, remember, the weirdest visuals might be the most scientifically accurate ones. Reality at light speed is as spectacular and alien as any special effects shot. And now, thanks to some brilliant experimentalists, we've caught a glimpse of it for real.